Good morning, everyone, and welcome to today's webinar in which Dr. Bruce Haycock, scientist at the Toronto Rehab Institute, will introduce their challenging environment assessment lab and tell us how QUARC helps them in their work. And now I would like to pass the microphone to my colleague and today's moderator, Hervé Lacheray. Hervé is a senior project engineer at Quanser and has a major role in development of our QUARC real-time control software. So I will let Hervé introduce our today's presenter.
Thank you, Susanna, and hello everyone and welcome. I'm Hervé. Today we have a very exciting presentation. Our guest speaker is Dr. Bruce Haycock from the Toronto Rehabilitation Institute, or TRI in short. Dr. Bruce Haycock is a scientist and the lead engineer for real-time computing at TRI's Challenging Environment Assessment Laboratory, or CEAL. He holds the status appointment as an assistant professor at the University of Toronto Institute for Aerospace Studies. Bruce's background and research focus are related to human-in-the-loop vehicle simulation, including simulation technologies, vehicle dynamics, and human control of vehicles. I first met Bruce back in 2009, right after Quanser started to work with TRI to set up the host computer system for their then nascent and still being planned challenging environment assessment lab. And right away I was impressed. Bruce was very hands-on from the beginning and had already been actively involved in motion simulation research. So for this webinar, we've asked Dr. Haycock to share with us some of the very interesting and exciting research that the software and hardware framework at CEAL enables. That being said, Bruce, take it away.
All right, thanks, Hervé. I'll just get so I'm showing the right screen here. All right, so as Hervé mentioned, I'm Bruce Haycock from the Toronto Rehabilitation Institute, and I'm going to show you a bit about our Challenging Environment Assessment Lab, which you could also consider as the unexpected activities hiding deep under the ground here in Toronto. So Toronto Rehab Institute is a member hospital of the University Health Network, along with Princess Margaret, Toronto General, Toronto Western, and a few other places. So it's a fairly large corporation. Toronto Rehabilitation itself is Canada's largest adult rehabilitation hospital, and it includes 5 sites, which includes the University Centre in downtown Toronto, where we're located, and it helps people overcome the challenges of disabling injury, illness, or age-related health conditions in order to live active, healthier, and more independent lives. From a research perspective, TRI is the top rehabilitation research center in the world. So some of the statistics from 2016 are shown here. I don't have the latest from 2017 compiled just yet, but it's about 50 full-time scientists on staff, as well as another 77 affiliate scientists, 126 total researchers, over 200 trainees on site, which produced just shy of 450 research publications in 2016. Our overall mission is to solve problems commonly encountered by people with disabilities and their caregivers. And we do that focusing on 4 areas: prevention of disability, restoration of function following injury or illness, enabling independent living at home, and optimization of the rehab system. At Toronto Rehab, we use a lot of simulation facilities in order to safely and accurately measure the difficulties encountered in the real world. We also evaluate the impact of new treatments, devices, and technologies developed at Toronto Rehab. We use the simulation in order to enable quickly moving from the lab to the real world. We can also use it to design experiences which would otherwise be too dangerous, expensive, time-consuming, or literally impossible to do in real life. And the research at Toronto Rehab is on the very top floors of our building and the very bottom floors. So the first 4 listed here, Falls Lab, Home Lab, Care Lab, and Climate Lab, are up on the 12th floor, which, while interesting in their own right, are not the focus of today's talk. The last 4 labs comprise the Challenging Environment Assessment Lab, or CEAL as we call it. It's the only facility of its kind in the world, and it's a massive underground lab 4 stories below street level. It contains a multitude of customizable testing environments using interchangeable, self-contained laboratory spaces. We sometimes refer to those things as payloads. So on the top of the screen there, you can see our big hole being dug a few years ago as the lab was being built. And then at the bottom, it just shows the current interior. It notably features a large hydraulic 6 degree of freedom motion platform. And it's the only one in the world of this sort used to mimic everyday environmental challenges faced by older people and those with disabling injury or illness. The payload shown here on the motion system is StairLab, so that's the one that I'll talk about first. So just a little video to give you an idea of how this works. This is a time-lapse camera of StairLab in action. So as you'll see in a second, inside there is actually a staircase. We have to tilt the room to get into place, so there it goes. And then when you're walking around, we actually shake the room in order to throw you off balance and look at your balance recovery reactions, like grasping of handrails, things of that nature. Inside the lab, we use motion capture systems, force plates, load cells in order to do the biomechanical studies of what the human is doing inside that space. One of the important things that we look at in StairLab is stair geometry itself. So we've even created staircases that have variable geometry. So you can see one of my colleagues, Dr. Alison Novak here, adjusting a staircase. And the research that was done in StairLab has been used to make stairs safer in Canada. So it actually rewrote the building code, increasing the minimum depth of stairs. And those changes are expected to prevent 33,000 injuries in the first 5 years alone, which obviously is going to have a huge impact on people's lives. Secondly, it's called StairLab because we do a lot of stairs research in there, but it's really a flexible biomechanics space. So sometimes we can even set it up as something like this with a bathtub in there and looking at getting in and out of bathtubs or bathroom usage for toilets, another cause of injuries in the home. Next up is Winter Lab, because we are located in Canada and we have to deal with winter conditions, which produces a whole range of real world challenges. As you can see here, filmed just down the road from us. So there's this lady and her friend who go walking across the road, and there's a whole host of things going wrong here, but it'll loop back again in a second. One of which is that we have to deal with slippery conditions. So this is a good little composite video actually showing Winter Lab and what goes on inside of it. It actually also shows another one of our motion systems. We have a single axis motion system to just tip labs when we don't need the full 6 degree of freedom hydraulic motion system. So in this case, the lab has been tipped up to 6 degrees. And there's another one of my colleagues, Roger, walking up and down the ice floor. And he's able to walk up it, but isn't able to walk down. This is one of the things that we do a lot of testing on is winter footwear, as shown here. So most winter footwear is commonly bought based on comfort, fashion, warmth, things like that, with very little regard to traction. And the problem is we're walking around in the real world where there's ice. So as our friends showed in that first video, traction matters. So here at Toronto Rehab, we developed a new test. We call it the maximum angle achievable, which we just have you walking in that winter lab up and down various slopes and see how steep a slope you can go up. And we figure you should, at the very least, be able to walk up and down access ramps and curb cuts where the curb is sloped down to meet the roadway. And those can be up to 7 degrees. So we figure that's a bare minimum for a pass. And that's considered one snowflake if you can walk up and down an ice slope of 7 degrees. A A slope of 11 degrees would get you two snowflakes, and 15 degrees for 3 snowflakes. So in the first year of testing these, we launched a website called ratemytreads.com, where we would put up all of our research results and test as many boots as we could get our hands on. That first year, over 100 boots were tested, and less than 10% of them managed to get that single snowflake rating. None of them had 2 or more. However, within about 3 weeks of that website going live, all the boots that had 1 snowflake, as in the highest rated ones, were gone from stores. You couldn't find them anymore because they sold out, and the rest of them languished. So over the year intervening between then and now, there's been a lot of winter footwear manufacturers in order to test out their boots and develop new boots in order to make sure that there would be better ones available this year. So that's another way that we can have a real world impact in order to change lives. In this case, it was simple economic pressure, as those boots that test well end up selling well. We're also involved with developing new materials for boots and new sole materials in order to improve winter traction. So here's Roger again. He's walking on a wet ice surface, which means that while he is in fact on ice, the air temperature above it is 7 degrees, so there's a thin layer of water, making it really slippery in there. But he's able to walk up and down that slope, no problem at all. The next lab I'll talk about is Street Lab, which is a virtual reality space. We use it for looking at multisensory integration, things like the interactions between listening and walking. It has a 240-degree projection screen, so that once you're inside there, it really is very immersive, that looks like you're in the world. So here's somebody walking across the road. The road they're crossing is actually University Avenue, right out in front of our space, but they're in the virtual world instead of the real one. It has a 7.1 surround sound system in there as well, so that we can recreate realistic soundscapes. So in this particular case, they're walking across the road and there's a bunch of people talking to them from different directions, and they're supposed to be responding about what that person was saying to them. It's also reconfigurable like all the labs. So in this case, we've taken out that treadmill, replaced it with a force plate instead, and just looking at balance studies. One of the biggest is there's a not well understood interaction between hearing and balance. Because although your vestibular organ is co-located inside your ear, so your hearing and your vestibular are in the same place physically, they're physiological separate mechanisms. However, if you have cochlear implants, which are there to improve your hearing, all of a sudden your balance gets a whole lot better as well. And that's not an interaction that's well understood. So that's one of the things that's looked at inside Street Lab. Finally, the fourth and newest part of CEAL is Driver Lab. So this is easily the most advanced driving simulator in Canada. It's comparable to the top simulators in the world, with unique features making it perhaps the most realistic driving experience. We use this simulator for driver assessment, looking at fitness to drive, particularly in the context of an aging population. And the prime driver for this is because mobility is important. That we live in a country where we use our cars to get around. So we have to be able to use it to get to the store. However, driving in rural Ontario is not the same thing as driving downtown Toronto in bad weather. So there's a question about perhaps we could do something around customized licensing in order to allow you to safely drive longer and just making better assessments about your ability to drive. It's also going to be used for looking at the effects of drugs on driving, including opioids is one of the biggest. Canada is one of the largest prescribers of opioids for non-cancer chronic pain, which helps those people live pain-free, but it does have an impact on driving that we have to take a closer look at. One of the other big pushes, I don't know where all the attendees are from, but very shortly, Canada is going to make recreational use of marijuana legal. So obviously, there's a lot of questions around the impact of that on driving. We're also going to be looking at drowsy driving. And of course, the other hot topic is autonomous driving and advanced driver aids. So Driver Lab contains a full-size passenger vehicle inside that dome, mounted on top of a turntable. The vehicle retains all of its original internal components. The steering wheel, the pedals, the seats, and the dashboard all look like they were in the original car. However, it also contains customizable interfaces and some sophisticated measuring tools, such as an eye tracking system. Our display is a curved dome which surrounds the entire car using high-resolution projectors to create a seamless 360-degree field of view, really immersive experience, which obviously requires several high-performance computers to render that virtual scenery, run our simulations, do the vehicle modeling, manage and synchronize the behavioral measurement devices, and record driving data. The idea of that being that once you're inside the vehicle, it provides a highly realistic and compelling scene in order to fully immerse you in that virtual world. So here's Roger again. We saw him walking up and down the ice. Now he's driving around in our virtual world. I mentioned that it had some unique features, one of which is a glare system, which makes use of some really high intensity LED panels to have a one-to-one recreation of the light reaching the driver's eyes from oncoming traffic at night. So in a normal simulation, another vehicle at nighttime is just two white dots drawn on the screen like you see on your monitor now. Which is obviously a very different thing than actually being in the real world and having that bright light reach you. So when you're inside this simulator, you actually have to deal with that brightness, which means that you can't look directly at the car that's coming towards you and things like that. And the reason for this system in particular is because only 25% of all traffic is on the road during the nighttime, and drivers tend to travel shorter distances. However, crash rates are the same at night as they are during the daytime. So after adjusting for the shorter mileage that motorists are traveling at night, you find that the fatality rate is actually 4 times higher at night than it is during the day. And crashes tend to be more severe at night. So this is an area of particular focus for us. Another time of day when people tend to have a lot more accidents is when the weather is poor. So rain is another concern. As such, the other really unique feature of Driver Lab is that it actually rains in our car. So there's real water falling on the windshield. You have to use your windshield wipers to clear it away, deal with all of the associated vision difficulties from driving around through the water. Things that obviously you don't normally find in a simulator because water and computers don't tend to play nicely. However, we do have rain in our simulator. Finally, I'll show you one more colleague that worked here. So this is Susan sitting at the control room, where all of the various labs are operated from when they're on motion. Obviously, there's many screens here for keeping us informed about what's going on inside the lab, such as interior and exterior cameras, which you can see. This is obviously Driver Lab that's on the motion system right now. So we have some cameras so that we can see inside the car and see the exterior of the car. And this is where we're able to control the various features of the lab. So if you're perhaps a more typical Quanser customer who's using their products for research or educational use in controls or mechatronics, you might perhaps at this point be thinking this is all very interesting, but what does that have to do with QUARC? And this view is actually a very helpful segue for me to make that point, because the layout of the information on this screen actually aligns pretty well with our software architecture. So on the left side monitor in this particular case is the driving specific simulation software, which does all of the rendering of our outside visuals and doing the vehicle dynamics and all that sort of stuff. On the far right side is the control screen for our hydraulic motion system. And then sitting in the center are some MATLAB and LabVIEW GUIs and a Simulink window, all of which are actually interacting with a real-time QUARC process. So there's a fairly close collaboration between QUARC and our lab CEAL if you've ever looked really closely, there's actually signs of this hiding around in QUARC, such as this checkmark on the installer for application block sets, which if you were to select that with, at least with the license that we have, gets you a selection of custom blocks inside the Simulink library for CEAL, our lab. So what specifically do we use QUARC for inside of MATLAB? Well, one obvious example are those custom blocks, which were originally delivered by Quanser from the original development of CEAL. As Hervé mentioned, started almost 10 years ago now, so it's been going on for a while, such as this one particular block, which actually implements the API for controlling that hydraulic motion system. We also use it for data acquisition, taking in a large number of analog and digital inputs, as well as analog and digital outputs for controlling various subsystems. One particular example, the one that's shown here, is some interfacing with our car. We also use this for measuring force plates, load cells, various switches and sensors inside of our labs. Another aspect that we make a lot of use of are the communication blocks, which we use to communicate with other processes, other devices, software packages, making use of the stream blocks. Primarily, UDP is one of our main things because of real-time performance considerations, but we also make use of TCP and sometimes some shared memory. These are also notable because this is how we interact with various user interfaces, including those MATLAB GUIs and LabVIEW GUIs, as well as Android tablets. More on that in a minute. The one other really significant thing that we use it for is timing, both the control of timing of the models and verification that it's behaving the way it should, which is absolutely one of the greatest draws of QUARC for us, is the relatively easy, inexpensive access to real-time, or at least acceptable soft real-time performance using Windows target PCs. So using Windows allows us to use some atypical hardware using the manufactured delivered Windows drivers. We also frequently make use of various QUARC functions for creating our own custom blocks, such as this one shown here, which implements the API for that driving software package so we can interact with our driving virtual worlds. So why QUARC? Well, as already mentioned, it's relatively easy, inexpensive real-time performance. Another really key factor for us is the very tight MATLAB Simulink integration. So I mentioned that we have various user interfaces making use of the stream blocks and connect to them from MATLAB GUIs. And these GUIs actually form the sole point of contact for the operator. So much so, in fact, that most of the researchers here at CEAL have no idea what QUARC is or what it does. As far as they know, we just use MATLAB. So they launch a GUI specific to their experiment, which will often launch some other elements related to the hardware in use. And then all experimental control, setting environmental conditions, triggering specific situations, all those things are done through this interface with all the details hidden behind the scenes. And then inside the actual Simulink model, we'll take in all the various data sources, save some relevant information to files, generate and send commands to various hardware, typically in an open loop fashion, and use state machines for supervising safety and experimental protocols. Now, personally, my background is in flight simulation, so people that know me from that context are frequently surprised to hear that I work in a hospital and wonder what the link is. And the answer there is much the same as the link with QUARC. And it's quite simply that with the use of simulators and virtual reality and controls and mechatronics enables a wide range of really unique and impactful research. So just showing a few of the recent research papers that have come out of this lab, looking at, as I said, a broad range of topics. We'll use StairLab looking at staircase geometry, poles for mobility aids, hearing and mobility, all kinds of really unexpected things. So with that being said, I'll open it up to questions and mention also that we're always open to visitors. If you happen to be in the area and are interested to see it, we give tours all the time. It's unintentionally one of the best kept secrets in Toronto. We're always telling people about it as much as we can, but as mentioned, people don't expect to find that under a hospital. And also collaborations. So if anyone has some ideas as a result of seeing that, and I've captured your imagination, and you think there's something really cool that you'd like to do in our labs, then you can get in touch and talk to us.
That was a great presentation, Bruce. Thank you very much. I really enjoyed it, and I like the level of details as well, and as well as the overview of the different applications that are happening underground in Toronto. And I have to agree that it's a very impressive lab to visit, and the researchers there are not only world class but also very approachable and friendly in terms of answering any type of questions you might have. So speaking of which, now is the perfect time to type any question you might have in the webinar chat box, and would be pleased to address them. There's some time left where we can answer some questions. Bruce, I really enjoyed the way you highlighted how you use QUARC and the main features and in the different contexts in which they are useful to you and your team for the research being done at CEAL. I sort of have a follow-up question in terms of the main benefits that are not only for the research but also for the researchers of using QUARC in the background, even though they might not be aware there's QUARC acting in the background. But what are the main benefits to the research and researchers at CEAL?
Yeah, so as mentioned, the main benefit from their perspective, I mean, so I showed Allison there adjusting the staircases. It's a good example. She's fully biomechanics background, so she's very familiar with biomechanics research, looking at mobility as you walk up and down stairs, but not so much with the low-lying data collection. So what QUARC allows for her case is we have a really tight timing integration so that we can collect force plate data, load cell data, and other things, and tie it really closely in time to things captured through the motion capture systems to a time fidelity well beyond what they would normally be able to get with just the motion capture system. And it's one of those, it's an added benefit for them to be able to look at things in such tight timing. But in addition, it's sort of a necessity as well, because we use the force plates sometimes for controlling the hardware. So other mobility labs will sometimes collect analog data through their motion capture systems. However, that's not an option for us because we have the ability to do things such as trigger shakes and have the lab move around just as you step on a particular stair. Or as a matter of fact, the case that's happening right now, if I were to flip on a webcam and spin it around so you could see out into the labs, there's people getting in and out of a bathtub, kind of like the example that I had shown, only just as you go to step into it, we throw you off balance and then look at balance recovery reactions. So we can trigger motion things at a specific timing off of analog inputs. So it really helps the timing for them. And as mentioned, the other huge thing is just the tight level of integration that it hides itself very nicely so that it looks like MATLAB and Simulink, things that people are more used to interacting with.
Yeah, this is really this is a great user type of application that here at Quanser we love to see. Let me see. There's another question. So someone is asking if someone wanted to use CEAL for product evaluation, for example, what would be the processes and costs involved?
So the process, well, step one would be to get in touch with someone here. The obvious contact is me at this point, since you would have my information, but you can also Google us, where our website is idapt.com, and get in touch with someone here in order to start the conversation about the process. The costs involved are one of those, it depends a lot on what specific elements of the hardware you want to use and how much of it you need. So obviously, when we're doing studies that require the full motion system, that starts to get a little more expensive than some other labs might be, because we have to consider maintenance of the hardware and having operators on station, things of that nature. However, we do a lot of sort of free or very low-cost work up front initially for piloting and things of that nature to make sure that it's actually going to work out. So most of the time, just to give a sort of ballpark idea of cost, it's very low cost, $50 an hour kind of thing, perhaps for really initial studies. Sometimes there's even some piloting done at zero cost. Up to the most expensive stuff is if you're using the driving simulation, which has many motion systems and requires a safety person sitting in the car and someone else to operate it, can get up as high as about $500 for commercial entities.
Okay, thank you, Bruce, for the additional details.
If you have also any other questions or would like to find out more about the Toronto Rehab Institute and the Challenging Environment Assessment Lab, here are some links where you can find that information. Also, if you are interested to learn a little bit more about the QUARC software, you can find more details on our website. So before we leave, I would also want to obviously thank you for joining us today. Thank to Bruce for being our presenter and walking us through their very interesting lab. And I had also a chance to visit it, and it's really, really exciting. It's the driver lab. Our next webinar in this user webinar session will be in 2 weeks. We will be hosting Dr. Zhaoxuo Jiang from San Francisco State University, who is doing a research into structural health monitoring, but more on top of it, he's developing a very interesting course in structural vibrations using not only a shake table platform, but also allowing his students to access the equipment remotely using a mobile app, so using their smart devices. So join us on Friday, February 23rd for the next webinar. We will be sending the invitations shortly. So thanks for joining us today, and looking forward to seeing you at our user webinars again in the future. Thank you.
Thank you, everyone.